All right, inverse functions, continuing with our graphing. So here are your notes for graphing, and I'm going to go over them fairly quickly. All right, so again, we're talking about inverses. So really, inverses are the reflection of a function over the line y equals x. Remember, this is our linear parent function. So let's look at these two graphs to explain what that means. This is our y equals that dotted gray line. And the black line is our original, f of x, which here f of x equals x squared. Remember from the last class, we switched the x's and y's. This is showing when we graphed our x squared and then we switched our x's and y's, we get this new graph that is in red. That is the inverse graph. Okay, so same thing with this g of x. That black line is that first g of x, the original. We flipped the x's and y's, plotted our new points, and we've got this red line. So that's what we're going to do to graph. So here's an example of our function and inverse. So let's first plot, come up with some points to be able to graph our original function, and then we will switch our x's and y's and graph the inverse. So let's start simple with -1. So if I plug in -1, 3 times -1 is -3 plus 4 is a +1. That's a 1. All right, let's do 0. Plug in 0 for x, so 3 times 0 plus 4 gives me 4. Let's do a +1. 3 times 1 is 3 plus 4 equals 7. And I don't know if our graph goes, let's do 2. 3 times 2 is 6 plus 4 is 10. All right, so I'm going to come over to my graph and I'm going to plot those points. Remember, we go x's first, and this is our x-axis. I don't think I can. This is our y. -1, 1. It's right here. Interesting. 0, 4, 1, 2, 3. There's 4. Why? 1, 7. 1, 2, 3, 4, 5, 6, 7. Oops, that's right here. Okay. And then 210 is off of our graph. So I can, my line's not straight. It's okay. Your line doesn't have to be straight yet. So this is our original f of x. Where's my, let's get a different color. All right, so now I'm going to flip my x's and y's. So my x here for my inverse, this is my inverse, is 1, -1, 4, 0, 7, 1, 10, 2. Now I'm going to plot those points. So we've got 1, -1, 4, 0, 1, 2, 3, 4, 7, 1, 1, 2, 3, 4, 5, 6, 7, 1 right here, and then 10 is off of our graph, so I can connect my dots to make my inverse function. I'll show you how to write this tomorrow. This is my inverse function in blue. So I've plotted points for my original function, switched my x's and y's, plotted points for my inverse function, and I have graphed both of those. And you can see that they are reflected over that gray dotted line. So if you're asked to actually graph them, that's how we do it. A lot of the times, though, we're just going to be given an original function, asked, and then shown a bunch of graphs and asked which one shows the original and the inverse. So we need to do all of the same thing again. Let me get my red back. So here is our original. This one's a little weird because we haven't seen x to the third in a while. So let's plug in -1. You might need a little bit more room if you want to write these down. -1 minus 2 times -1 to the third. The -1 is to the third, so it's -1 times -1 times -1. So that's -1. So we got 1 minus -1 minus 2 times -1. Okay, so since we have the -2 times the -1, that turns into +2. So then we really have -1 plus 2 equals a +1. All right, let's try 0. -1 minus 2 times 0 to the third. 0 to the third is 0, so -2 times 0 is 0, so -1. Let's do 1. -1 minus 2 times 1 to the third. 1 to the third is just 1. So then -2 times 1 is just -2. So this one is -1 minus 2. The negative minus makes it bigger, so it's -3. And then do 2. It's not going to let me erase. Whatever. I don't care about that fourth point. So let's look at our graphs and see where these are. So -1, 1. It's kind of hard to tell on these graphs, huh? -1, 1. Well, it'd be right there. -1, 1 would be right there. 0, -1, that would be right there. 0, -1 would be right there, and right there. And then 1, -3 is not right there. I'm not even touching this board, guys. 1, -3, 1, -3 in the middle of that square somewhere. Okay, so it looks like this one shows our original graph. None of the others show our original graph, so this one must be, I should change my colors, should be the inverse. So this graph would be our answer. But we know we can look at it and verify if this is our answer. Oh, I erased it off. Good job. That's blue. By switching our x's and y's. So then our x would be 1, -1. Yep, that's on the green. 0, -1. Yep, that's on the green line. Oh, I did that wrong. 1. Nope. Guys, come on. What's wrong with me? Erase. Okay, so there's our 3 points. It is on our line here, so this must be the inverse. So that must be the answer. So these are the kind of problems that you're going to see. You're going to be given the original and then given a couple of graphs, asked which one shows the original and which one shows the inverse. Plot some points for the original and figure out which graph shows the original. Plot some points for the inverse, figure out which one shows the inverse. And let me know when you have questions.